Welcome to this webinar reviewing the new data management and mapping features in our 2022 GeoGraphix release. Now in this webinar, we'll be reviewing a new tool for georeferencing image files on GeoGraphix maps, a feature for calculating and thematically mapping grid statistics over legal polygons, a brand new interval type for characterizing completion and rock properties along the wellbore, some added capabilities for querying and posting key production metrics for horizontal wells, and a utility to bulk export Isomap layers in Zmap Plus format. Okay, let's look at the new georeferencing tool in GeoAtlas. You access the tool from the Tools menu and hit the georeferencing menu item. We have a new dialog that comes up. The first thing you really want to do is go ahead and pick the image that you want to georeference. So I'm going to pick this image called Missouri River, and I'm going to georeference it onto the map. Now a good way to do this is to use some cultural data so that you can figure out, where your control points need to be. Now I'm going to go and zoom in a little bit here and try to pick some control points off this map. Now roads are good, right? Roads work. Rivers, not so much, because rivers move. So we'll try to use roads as our control points. So I'm going to go ahead and zoom out a little bit here and pick our first control point. And if I go here and take a look, it looks like I might be able to get a control point right here at the corner of this section line. So I'm going to hit the control point here and see if we can do that. It looks to me like that is your first control point. And I'll go ahead and reference it to this point on your GeoAtlas map. You can see that we have one control point, but we can add more. Generally, you want to add 2 or 3. And let's see, let's look at, this is actually a good place right here for a second control point, because there's a road right here and you can see the junction. I'm going to go in there, and it looks to me like that is the point we need. Okay, let's do another one. Looks like there's a junction and a road right there between 2 roads, and we'll use that control point. You can add as many control points as you want, but generally 3, 4, 5 is enough for a good georeferenced image. And we're going to go ahead and georeference that image, and we'll just call it Webinar Missouri River 2 and save that. And we'll put it on our map. There you go. Now I'm going to go ahead and move into layer display attributes here, and we'll add a little bit of transparency to it and maybe a little bit of contrast so we can see how we did. So you can see where your river is here, and you can see your new georeferenced image. So that's how easy it is to use the new georeferencing tool. Basically, go ahead, bring it up, select the image that you want, pick your control points both on the image and then on the map, georeference the image, which creates a world file for you, and the image automatically appears on the map as an image layer. Now I'd like to demo a new feature that helps calculate key production metrics for horizontal wells and helps answer the question, well, what well's the better well? In the example below, is it the 6,000 lateral foot well producing 500 barrels per day, or is it the 3,500 foot well producing 350 barrels per day? Well, just looking at it, you'd probably say it's the well on the bottom. What if we're just talking about perfs? Maybe the well on the top didn't get landed in the right spot, or you're out of the zone for a little bit, or perhaps they hit a fault and the drilling crew couldn't perf that area. Well, now it becomes a little bit more difficult to answer the question, well, what's the better well? 2022 release, we can calculate key production metrics at 3, 6, 12, and 24 months, and really any other number of months you specify. Some of these metrics are the first n months production per lateral foot, the first n months production normalized to 10,000 lateral feet, and the first n months production per perfed lateral foot. First, let's look at a number of new production statistics fields that we can use to create well filters in Query Builder. Now these are key production metrics. We've added about 20 new fields, and all of them are calculated. That means the data isn't stored in the database, but the results or the metrics are actually calculated on the fly when we execute the filter. Let's just go ahead and run that filter. And you can see that I'm asked to input a few parameters. How many months production am I interested in? I'm really only interested in the first 3 months production. The producing zone, this is the Niobrara. Niobrara is a prolific oil producer out here in the DJ. And I'm also asked to input the inclination of the well at the landing point. Hit OK. Now I'm also want to see the lateral length for the wells, and I'm just going to use the same inclination and run the filter. It only takes a few seconds to run the filter. And now let's take a look at the results. Now it's important to note that the production here has been normalized to 10,000 feet of lateral. Now this is so that we can compare production between wells of different lateral length. And of course you can see here that all of these wells have significantly different lateral lengths. Now these calculated metrics are very useful. Not only can we use them to create sophisticated well filters, but we can also export them for display on maps and layers. Workflow, pretty straightforward. Just export your results. Save the CSV file. And now I'm going to use these metrics in Zone Manager to build my map layers. Now I've set up my import. I'm going to go ahead and import that data into Zone Manager. And then we can start making map layers. Now let's create a WellBase layer for the first 3 months normalized oil production for my Bill Barrett wells, and then show that as production bubbles on a map in GeoAtlas. So I'll go and I'll create that layer. And host zone attributes. Now remember, we're using the Niobrara as our zone. That's the zone that we saved first 3 months production to. And we'll go ahead and create that layer. Now, I only really want to create that layer for my Bill Barrett wells. And we'll call it Bill Barrett first 3 months normalized production. I've already created that layer, so I'll just show it now. And a few interesting things show up. We take a look at the wells on the pad in section 27 and the wells on the pad in section 2 and see some stark differences. Zooming in a little bit, the wells on this pad, basically they all produced around 35 to 45,000 barrels per oil over a first 3 month period on a normalized basis. If we zoom out a little bit and take a look at the wells on the pad in section 2, we can see on a normalized basis they're only producing about 25 to 30,000 barrels over the first 3 months. Now even though the EURs of these wells ended up being really similar, we can easily see that the oil production for the wells for the pad on the left was quite a bit better than, at least on a perfed foot of lateral basis, than the wells in the pad on the right. Now perhaps this is a function of well spacing or some other mechanical property or rock property, but now with this new tool you have a basis for comparison. Now this feature becomes even more powerful when you're able to compare first 3 months production or first 6 months production for your own and your competitors' wells. And I've done this here. Now these wells that I'm just show you here these are wells that were spudded and completed in the same 3-year period as the Bill Barrett wells. Interestingly, the Bonanza Creek wells tended to produce better over the first 3 months than the Bill Barrett well. But again, having a basis for comparison is important, and it's this visual comparison between production of your own and competitors' wells normalized by per foot of lateral that makes this new calculate production feature really shine. Now let's take a look at the new interval data management tool that we added for the 2022 GeoGraphix release. A good way to think about it, or at least a good analogy, is to think about the tool in the same way as we think about zones and zone attributes in Zone Manager. In Zone Manager, you can define a zone. Usually it's defined by pixels in every well, and then you can assign attributes to that zone. Maybe it's porosity or gamma ray or organic carbon. But you can only assign one attribute, number, string, or date value per zone. So in this case, this zone is 200 feet in the well, you would have to assign an average gamma ray or an average porosity to that 200-foot zone. With intervals and data fields, you can assign more than one number, string, or date value along the interval. Here we have an interval called pay, and we have a number of data fields associated with it: porosity, gamma ray, organic carbon. But I can assign a porosity at every 1 foot interval along that pay. So that's the difference between how we handle zones and zone attributes in Zone Manager and our new interval and data field feature in the 2022 release. Okay, now let's take a look at the new interval management tool. You can see here in WellBase that we have a new intervals tab. I'm going to go ahead and select that, and I have a one well filter on. And what you can see is a new tab, and I'm going to open up the interval management dialog. A couple things you can do here. One, you can add a new interval, and I'll just name this interval pay. And then you can begin adding data fields to that interval. So I'm going to add a few, and one of them is going to be porosity to this particular interval. Porosity will be %. I'll give it a description. And I also want to add a porosity descriptor. Now this is going to be a text data field. And I'm just going to have two descriptors, high and low. Just areas along the wellbore where you have high porosity and areas along the wellbore where you have low porosity. Great. I'll go ahead and create those and say OK. And you'll notice that there's a new field, actually a new column in the grid. Every time that you add a new data field, a new column will show up, both for text, date, and numeric data fields. So now my pay interval has two data fields, one a text data field and one a numeric data field. If you want to get data in there, pretty easy to do. You can go ahead and, well, one thing, you can just go ahead and just paste it in. That's easy enough. Or you can use the spreadsheet importer. And I'm just going to go ahead and paste it. And you'll notice that a couple things happened. One, all the formations were calculated for every interval. So, and those are being calculated from your formations table. This is a horizontal well, and of course you're going to have more than one Well, if the well is out of the zone, you'll probably have more than one formation pick for the same formation. Here we have 3 picks for the Niobrara formation and 2 picks for the Carlisle formation. Those are actually calculated automatically for you. If you want to calculate them or you want to calculate them in bulk, you can use the Calculate Formations tool. And we have a new well data type here called well intervals. I'm just going to do that for this particular well. And I'll say OK. And now your formations are calculated. Now if you want to add other data, let's say porosity, certainly can do that from the spreadsheet loader. I'll just go ahead and bring this data in, copy it into that field, paste it right in. Same thing for text data fields. Copy it, and paste. If you want to delete a field, very easy to do. Just go ahead and delete the data field that you've selected. And you can also merge intervals. So let's say you had overlapping intervals for some reason, and you wanted to merge those intervals. You can go ahead and do that and specify what type of merge you would like for the porosity data. So for instance, if it is porosity data, do I want, and I'm going to merge maybe 2 intervals to create, a much larger interval. What do I want to do with the porosity values? And you can do a number of different things. You can take the porosity value at the minimum depth, you can take it at the maximum depth, or you could take the average, or the sum, or the min or max. Now that's all we could do with interval data. Well, it wouldn't be terribly useful, but we can do an awful lot more. We can work with the interval data and create maps and layers on it, and characterize completion and rock properties along the wellbore on your maps. So let's do that. We want to display interval data to characterize properties around the wellbore. So I'm going to make a few WellBase layers that illustrate the usefulness of this new feature. So let's go ahead and create those layers, and they will be WellBase layers. And you'll notice that we have a new interval database table. Now I'm going to bring over the type first. In here I'll select the pay. Remember, this is the pay zone. And I'll select formations. So in this way we'll be able to display the lithologies along the wellbore. I'm just going to select a one well filter, just in this interest of time. And I'll say 2. And we'll create that filter. Now, you have a lot of extra posted text here, but we're going to go ahead and get rid of that. Turn that off. We don't really need to see it. You'll notice that we have a new entity type as well as some new renderers for the entity. Now I'm going to first say we really don't want to see the line, and I'm going to go to my thematic renderer, and we'll pick formations and give that formation, make that one limestone, and I'll make that one sandstone, and I'll make that one shale. We want to be able to see. So we'll widen the line a little bit and preview. And there you go. It's very easy to see the different formations, or the different lithologies that the wellbore is intersecting in the horizontal part of the well. Now let's do one more, and another wellbore layer, And remember, we created two data fields, one porosity and one porosity descriptor. I'm just going to go ahead and select porosity. You can select it from the data fields, pay, and porosity. Make sure I apply that filter. Give the layer a name. Same result. But we can use those renderers and layer display attributes to render the porosity along the wellbore. This time let's use the graduated colors renderer. Now first I'll go ahead and we don't really need to see the extra line. Porosity 2.8. We have that up. Let's have the number of intervals. We'll change that to maybe 10 so we can see a bit more. And of course you want to increase the weight of the lines so you can see the results. And we'll preview that. Take a look at what we got. Oops, I'm going to actually turn off the posted text too. I think I'm going to go ahead and make the lower porosities a little cooler, maybe the higher porosities a little warmer, so we can see it a little bit better. There we go. Again, with the new tool, it's very easy to display or characterize completion and rock properties along the wellbore. And remember, you can pretty much characterize anything. Anything can be a data field. You just have to create an interval and create data fields for that interval. Each interval could have 20, 50 different data fields associated with it, and then you can use the rendering capability in GeoAtlas to characterize that data along the wellbore. And certainly you couldn't do that before, but we've made it very, very easy to do it now. So that's all I have for this feature, and let's go on to the next one. In our next demo, I'm going to demonstrate a nice way to calculate grid statistics over legal polygons. And really, you can calculate grid statistics for any type of polygon that can be imported as a shapefile. Now first, I'm displaying a legal polygon layer on the map. In this case, it's a layer with township and range section polygons. Next, I'll go to the Tools menu and invoke our new Grid Statistics tool. See a little cursor here. The first thing I'll do is I'll select some legal polygons, some sections. Now I can go ahead and select the grid that I want to use. And you can select the Isomap layer. In this case, I'm going to select my webinar Isomap layer and select the type of statistic that you'd like to calculate. In my case, I'll just select the average, but you can select median, standard deviation, and minimum and maximum also. It's a good idea to use your column options to select some labels that help you identify the polygon. So I'll go ahead and do that. Expand this so you can see it, and then extract the grid values for those polygons. So see here we have an average grid value, an average value extracted for each of the legal polygons, and this is coming directly from the Isomap layer. Now your Isomap layer could be any rock property. It could be organic carbon, or it could be vitrinite reflectance, or it could be porosity, permeability. It's simply up to you. Next, I'm going to go ahead and create a layer, and I'll just call it Webinar Grid Statistics Layer 2. And that new layer appears on my map. So what can I do with it? Well, you'll notice that we have a new statistics polygon entity for this LandNet layer. This is an entirely new entity for LandNet layers, and a number of renderers associated with that entity. Now I'm going to go into my graduated colors renderer, pick average because that's what we calculated. I'll increase the number of intervals a bit, and let's see, I'll make that a hot color, and maybe that a cooler color, ramp it up, and then preview. Okay, so what we're really done here is we've taken all the grid cell values, averaged them, and applied them to the legal polygon. It's also worth noting that in addition to calculating grid statistics over polygons, we're now able to extract grid values along the wellbore and save them as data fields in the Intervals tab. For instance, I want to extract vitrinite reflectance values from this well from an Isomap grid of vitrinite reflectance. So, I'll select the well on my map and generate that interval data along the wellbore. You can select any AOI and any Isomap layer that you'd like, and I'll select the webinar Isomap layer of my vitrinite reflectance values. Go ahead and select your interval type and the data field, and I'll save that. Now the interval data was generated for this one well, but if you selected multiple wells, you could do it in bulk. And if I go to WellBase and update, you can see that I now have extracted those reflectance values along the wellbore for this well. Now these values are saved as data fields here in the Intervals tab, but they can also be used in petrophysics as input curves for your user-defined equations. Finally, I'll demo a small but useful feature to bulk export Isomap grids in Zmap Plus format. Large GVERSE GeoGraphix projects can often have hundreds of subsurface layers and dozens of AOIs, and exporting these layers one by one to Zmap Plus can be a chore. So we've lessened the burden by letting you export them in bulk. Let me show you how. Very simple. Just go to File, Export, Surface, and select the new Zmap Plus bulk export. You can select your layers, and here I'll just select these 4 layers. Always good to give your file name a prefix so you know that it's a Zmap Plus file. You can export your data points, your grid, your contours, and your faults, and export the clipping and volumetric polygons on the layers. You can also select the coordinate reference system you want to export the data in, and then simply finish. It'll export the files, and if we go to where we exported them, it automatically creates a directory name, the same name as the AOI name, and exports these files to Zmap Plus. Well, that's all we have for today's webinar, folks. Thank you for attending this review of the major new data management and mapping features in our upcoming 2022 release. Thanks again for attending, and have a wonderful rest of your day.